Recall, I wrote, in Math 10, you learned that equations of the form y equals mx plus b are called slope-intercept form. And you learn that we define, by the way, they're rulers, they're not swords, they're not helicopters, don't poke your eyes out or I'll make you wear safety goggles, so back focus here. In other words, put them down. First, we define slope as, you all learned this in Math 10, if I say to you, oh, leave the headphone out, always. If I say to you, slope is what over what? Okay, so you can write here, it's the rise over the run. I had a math teacher, she actually did it this way. She always wrote the word rise with a Y, even though that's spelled wrong, to remind her students the rise was the Y's, the vertical. I always just remember the rise is the Y's because that rhymes, and the run is the horizontal. Whatever works for you. And then you're also given a slope formula. You're told that if you don't have the graph, if you can't just go rise over run from the graph, if you have 2 points, you can go y2 minus y1 over x2 minus x1. Jocelyn, I've given you that slope formula. I don't think you'll ever need to use it this year. You'll always have the graph. But I put it down because as a math nerd, it's dear to my heart. When I teach math, I often call this slope formula, y2 minus y1 over x2 minus x1. I often say it's the Swiss Army knife of mathematics. Much like you can use a Swiss Army knife all over the place. With a bit of cleverness, it turns out, Nicole, you can use this all over the place. In fact, if you ever take calculus, you derive, when I taught, I would derive almost all of calculus starting with that. Can be done, if you're clever. So I like it, but most of the time this year, you're going to have the graph. So I wrote here, complete the following on the grid on the left. We're actually almost done this introductory unit, so you're going to hear me starting to drop hints about tests. On your test, you can expect to see a question like this. I'll give you a grid. I'll give you 4 or 5 equations to graph, 1 mark each. So I'm going to pick on Rylan because he needs to remember his name occasionally. Rylan, my friend, what is this equation? I'm going to answer this the question. I'm going to tell you. It's a line. Does anybody know how can you glance at an equation and instantly, without thinking, realize that it's a line and not a curve? This one is so obvious that often teachers don't explain it, and I've noticed. Look up. I'm going to make this a curve now. Look up, look up, look up. Don't write this down. Now it's a curve. Or, now it's a curve. Or, you know it's a curve if it has exponents or square roots or tangents or weird stuff or anything like that. So this year, in grade 11, you are going to be learning in your math classes curves. And you're going to notice, oh, I can tell it's a curve, it's got a squared. Or I can tell it's a curve, it's got a square root. And you'll actually memorize what the square root curve looks like, the same way you memorize the y equals mx plus b deal. Or you'll memorize what the squared curve, the parabola, looks like, much like you'd memorize what this looks like. So how do I know it's a line, Rylan?
If it's not square.
So is that a line? Say yes.
Yes.
Is the y by itself? In
Yes.
example 1, then I can graph this, and I can graph this in slope-intercept form, where the slope is symbolized with an M. Why do we use M for slope? Because not all math was done by English-speaking people. I think the M comes from the French word for mountain, slope. And we call this, Rylan, this number after the x, B, the y-intercept. So how would I graph this?
Put a point on -4.
It turns out even though we write the slope first, y equals mx plus b, you graph the b first. So put a dot at -4 and then count how?
Up to and then to the right 3.
Up to over 3, up to over 3, up to over 3. Oh, and I can go down to back 3, down to back 3, down to back 3. There's a line. I'm going to try and connect the dots. In your notes, you can freehand on a test or in homework, use a ruler, since I loaned you one. It's really tough for me to draw lines. I'm like, oh, that's pretty good, actually. What equation number was this, Rylan?
1.
I'll put a little 1 there just so that when Mr. Dueck is marking, because I'm going to give you an identical question just with different numbers on your quiz, he can figure out which line is which. There. Adeem, look at number 2. Is that a straight line? Is that a line? How do you know?
It's a straight line because there's...
By the way, all lines are straight. That's a redundancy, but that's okay. It's a line. How do you know?
Because it's not raised to a power greater than...
No weird stuff. If you really want the short version, no weird stuff. An x and a y, no squared, no cubes, no whatever. Okay. Is the y by itself?
Yes, it
Well,
is.
then this is in slope-intercept form. Excellent. What would the y-intercept of this line be?
Positive 5.
So I would go 1, 2, 3, 4, 5, 5, right there. On the y-axis, which is why it's called the y-intercept. By the way, hopefully I'm brushing cobwebs off and you've forgotten, but this is all coming back to you. If you actually still had this fresh at your fingertips, good. What would the slope be?
Negative 2 over 1.
How would I count?
Down.
Down
2.
2
And
over 1. Nice. Down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. Line number 2. Cody, my friend, look at the third one. Is that a line, and how do I know? Yeah. Say yes.
Yes.
How do you know? Are there any exponents or squareds or weird stuff on line number 3? Do you see a squared on the y? Is the y inside a square root? Is the y inside anything weird? However, what's weird about that line? What letter, what variable is missing? An x. In fact, how many x's are there in that equation as a number? No, then there would be an x there. Sorry, say that again, Dylan. Cody, when I look at example 3, I actually see it in my head like this. I will never write it like that. But if there's no x, Drake, I would argue no as a number means 0. And now I've got it in my head looking like slope-intercept form. Because now, Cody, looking at this, what's the y-intercept, my friend? Caught you mid-stretch, I know. What's the y-intercept?
0,
Nope.
8,
Nope.
y.
Folks, what's the y-intercept here? Negative 8, right? So we would put a dot here. And, Cody, here's the key part. What's the slope?
That would be 0.
What does a slope of 0 look like?
straight line.
All lines are straight, Captain Obvious. What does a slope of 0 look like?
Oh.
By the way, kids say that, you can see I was ready for that because every year I've taught that, someone has said that same thing. You don't mean straight, you mean a word that begins with letter H. Horizontal line. No, we just had lunch. Should have gone then.
Well, sorry, I didn't have to go there.
You got to wait for a bit.
Sick.
Okay. Example 4. Duncan, my friend, looking at example 4, is that a line, and how do you know? Okay. What's the y-intercept of example 4?
0.
Ah, this is technically that, and that's what I see in my head. I will never write that. That's extra writing, Ariel. You can't make me do that, but I will see that. So the y-intercept would be 0. What would the slope be, my friend? So how do I count?
1 down, 2 to the right.
1 down over 2, 1 down over 2, 1 down over 2.
So that negative count belongs to the 1.
The negative tells you count down. Here's what I'll tell you. The negative can't belong to both at the same time, because what that would mean would be a negative over a negative. But what's a negative divided by a negative?
Well,
See, that's how I know that it doesn't go that way. You can technically put it on the 2, but that's bad math manners. We put it on the top. Is that okay, Evan? Well, look at number 5. Evan, looking at number 5, first thing, is that a curve or a line, and how do you know?
That's one of those terrible.
I'm just saying, as a shape, number 5, is that a curve or a line, and how do you know? You think it's a curve? What tells you that you think it's a curve? Look at the x and look at the y. Is there an exponent on the x or the y?
No.
Is there a square root on the x or the y?
No.
Is there anything funky or weird on the x and the y?
No.
Then it's a line. Okay? It's going to be a line, and that's help. In other words, if you know what it's supposed to look like before you start, I would argue, Evan, that's a win, right?
Yeah.
Now, what's weird about this? Is the y by itself?
No.
Then we're going to have to get the y by itself. You did this last year in Math 10. Now, here is my thing, Ethan. I want my students to become expert at this. So I'm going to tell you that if you can do most or even all of this in your head, great. I'm fine with that. We have to get the y by itself. Evan, my friend, how would I get the y by itself?
You have to get the x and then.
Okay, look up. What's in front of the y right here? A negative what? 3? You know what I'm going to, I don't like that negative. First thing I'm going to do is I'm going to move the negative 3y to this side. Look up, don't write this down. I'm going to show you how you can show work, minimum work for maximum buck. I'm going to move this to the, it's going to become a plus 3y. Is that okay, Ed?
Yeah.
But all I'm going to do to show that is that I'm going to let you use your Sesame Street imagination to imagine it there. Jared, don't be distracted. Okay, face the front. Is that okay?
Yeah.
So in my mind, on the right-hand side, I'm seeing 9 plus 3y. Sesame Street imagination, you can see it too. I can now, in my mind, have the y on this side. Yes? I need to move the 9 over. What's in front of the 9? It's invisible, but what sign is technically in front of that positive 9? A plus, so how will I move the 9 over? So here's what I'm going to write. I'm going to do some in my head, but I'm going to argue, listening to you. You're saying this is that. You said I could plus the 3y over? Yes?
Yeah.
And you said I could minus the 9 over?
Uh-huh.
Is that okay doing that in one step? You with me okay?
Yeah.
Now, have we got the y by itself yet? Not quite. What else is in front of the y? What's the 3 doing to the y mathematically? Adding, subtracting, multiplying, or dividing? So how would I move it over? What's the opposite of timesing by 3? So again, I don't like rewriting stuff. I'm going to be okay, look up, if you do this. I'll change colors so it stands out. You don't have to. If you did that, and what's 9 divided by 3?
30.
If you did that, I'm as far as I'm concerned, right, because I'm less concerned about the equation. I want the graph. If you can graph it right from there, good. In fact, being perfectly honest, when I taught Math 10 honors, I would actually push my kids to do that whole thing in their head showing no work, not even the 2x minus 9 equals 3, to do the whole thing. And if you can get that good, once again, Jaden, I will assume that you're not foolish enough to just be copying the answers, because I give you the answers to most of this stuff. I'm going to assume that you got that good. Okay? I am going to really push you guys this year, Joseph, to try and rearrange equations up here. Most of you will love it because you'll get good at it and it's a shortcut. A few of you at first will find it tough, but trust me, I've been doing this for, holy smokes, 17 years, and I haven't yet had a kid that A, couldn't get really good at it, and B, once they got really good at it, went, this is the best shortcut ever, because it also cuts way down in your memorizing. And I did my memorizing sucks rant already, right? My Richard Feynman cat, I think I did. Okay. Now, Evan, my friend, we got the equation, we got the y by itself, we know it's a line. What's the y-intercept, my friend? Nice. Right there. And what's the slope? Which means count how? All right, up 2 over 3. Up 2 over 3 and back count. And, you know what? Actually, I noticed that it's parallel to line number 1. You may recall from Math 10 that parallel slopes had the same, parallel lines had the same slope, and you may even recall something about perpendicular lines being negative reciprocals or something like, I'm not going to worry about that. That is, Drake, in 8 minutes, okay, that's a fib, 12 minutes, what you did probably in about 2 weeks in Math 10. You awake? Because your eyes were shut and you were in a little drool, okay? I don't know. Ah! No? No. Ah, my aim was off. I'm sorry. I got Italian. Ah! My aim was off. Got to do better than that. I'll work on it. Drake, read along with me. It says this. Usually in physics, you're going to be graphing in the first quadrant. Usually in physics, Dylan, we'll be graphing up here because usually we won't have negative data. So although I've walked you through generic equations, Riley, most of the time our equations will be in the top right corner. Not only that, because we're graphing data, there are some extra rules. On your test for this unit, which is going to be in about a week and a half, and I'll give you more details as we get closer, the very last question, Cody, I'm going to give you some data to graph. It's going to be a chart. It's going to be something. Okay? Most of the kids get the graph right. Where they lose the marks is they forget all these rules that I'm about to give you. So when you're studying, please make note of these rules here. First one, if you're graphing data, you have to label the axes. You have to label your x-axis, and you're going to label it with the English word distance. The variable that you're going to use, d, and the units, meters per second. If you do not, Jocelyn, I'll take a half mark off that graph because I don't know what the heck you're graphing. Then it's just dots on a page. It's finger painting as far as I'm concerned. So rule 1, label your axis. Oh, and a little note, time is you know what? I'm going to say almost always on the x-axis because there is one lab that we might get to later on this year where we are going to put time on the y-axis because the curve is nicer. But when in doubt, time goes on the x-axis. Second thing, select an appropriate scale. Try to have your graph fit as much of the page as possible. Ethan, if I give you this much graph paper and your graph takes up that much room, that's a dumb scale. You should have maybe gone up by 2s or, go up by half or something. Try and go as far this way as you can and as far this way as you can. Make your graphs pretty. You can use, Cody, a different scale for either axis. You may go up by 5s on the x-axis and up by thousands on the y-axis. It just depends on your data. Okay? Thumbs up. Number 3, I will take marks off if you do not give your graph a title. The easiest title is always what's on the y-axis versus what's on the x-axis. Mr. Dueck, I want to give my graph the title, The Rainbow-Colored Unicorn. No, a science title, please. I've had one kid that's a title, Mr. Dueck. No, it's something that has something to do with the graph. Other kids have thought of that joke. Next page. Plot the points. Graph the stuff. If you have a measurement with, now, if we were doing, Robbie, a good lab, if we had a measurement with some amount of error, you would actually, instead of putting a dot, you would put error bars. Instead of being points, they'd be these little bars. Now, here's the problem. We're going to have so much error that if I do that, the graphs are going to be yucky because I got lousy equipment. So we're just going to pretend, Simone, to make it easier that all of our graphs are accurate. So I wrote here, if we have measurement with some amount of error, draw a circle or a cross to incorporate that measurement. We're going to ignore that. We're just going to assume we're accurate because I don't have money in the budget to get the good equipment. I'm working on it. If your data points seem as though they're in a straight line, all lines are straight, Mr. Dueck, you're right. In a line, draw the best line that averages the data. Don't freehand, use a ruler. Put your pencils down, look up. I'm going to show you what I mean with the sketch. If you go, oh yeah, that makes sense, you don't need to write the sketch down in your notes. If you go, oh, I didn't know that, you can copy it down after I'm done. Ready, Evan? Yeah? Here's a graph. Don't write this down yet. Supposing you were graphing some data and you got that. Certainly there's a trend. It's going that way. If we were doing a stats class, I would teach you something called least squares regression analysis. But the problem is to do least squares regression analysis, even just for 5 points, takes about half an hour to do it by hand. I'm not into that shit. I'm really not. Shane, I'm not going to do that. If you have a fancy graphing calculator, it will do that for you. Yeah, you know what? We're not. We're going to do a very low-tech method. What we're going to do is we're literally going to lay our ruler down and try and go through as many dots as possible and then split the difference. Try and have as many points above and below. That's going to be our best fit line. Jocelyn, here's what we are not going to do. Here's what you don't do. You don't go connect, 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 connect. That's not a line. Instead, and I'm going to eyeball this here, for me, my best fit line probably would be about like that. Now you'll notice, how many points do I have grand total? 5. How many did I go through? Only 1. How many points do I have above, though? 2. How many below? That's not bad. But Ariel, it's also possible that when you graphed yours, you might have laid your ruler down and you might have done, because this would also be acceptable, that one. I'd give you full marks for that. Because we don't have the stats ability to do the exact best fit line, we're eyeballing it, I'll take a fairly wide range, Duncan. And a lot of the time, when you're looking at my answer key, you know, oh, I'm close, I think I'm right, but our answers won't be identical. So when I talk about a best fit line, that's what I mean. Go through as many points as you can, but also split the difference above and below. Do not connect them like a jigsaw puzzle. Is that okay? Now, if you can't remember that, then maybe you want to jot that diagram down, or if that makes sense and you've got it up here, we're good. Then, you're going to determine the slope of your best fit line. How? You're going to find 2 points on the line. Now, if I was finding the slope of this line, Jocelyn, what I would now do is I would put maybe a dot there and a dot there. Even though I'm going to ignore all the other points, I'm only going to use the points on my line. In other words, I would not go rise over run from this black dot and that black dot because they're not on my best fit line anymore. But now I would go rise over run. Delta y is our abbreviation for rise. Delta x is our abbreviation for run. Find the slope. Either show me what you did on the graph, or you can show me what you did somewhere on the paper, but somewhere I want to see, Jaden, your slope calculations. Look up. Cross this out. I'm not going to worry about sig figs for our graphs, because our graphs are going to be so, our data is going to be, Drake, so inaccurate to begin with. I'm going to meh. Won't worry about sig figs. Not on a graph. And then the very last thing you're going to do is you're going to find the equation. I started this lesson out, Robbie, by actually giving you equations and saying graph them. That's actually, we're going to do that very little in physics. What we're often going to be doing is, here's the graph, what's the equation? How would you do that? Well, you find the y-intercept, you just read it, and you find the slope by going, slope is what over what? Rise over run. Okay? I think we should give it another shot. We should break up, and I can prove it. Here's a graph of our relationship. Huh. Maybe you're right. I knew data would convince you. No, I just think I can do better than someone who doesn't label her axes. And guys, you can do better than someone who can. So I got that one, and give you one more. Nerd humor. Always label your axes. Okay. No? Tough audience. We're going to do one together, and then we're going to do an activity for the remainder of class. So, face front, thank you. Here is a graph. Behold. It says graph the following data and then analyze the graph by finding the equation of the line best fit. In the first column, what's that? What are we measuring? Let's label, time's going to go on the x-axis. So the first thing I'm going to do is I'm going to write down here time t, and then I'll put the units in seconds. That would have gotten you half a mark on the test question. Nick, what am I going to put on the y-axis? It says V. What did V stand for in Science 10 in meters per second? Okay, so I'm going to write sideways because it fits easier. Velocity, comma, V in meters per second. Step 1 was label your axes. Step 2 was give your graph a title. You know what? Velocity versus time. The easiest title. You could get more specific if you knew what this was. Velocity versus time for a remote control car over a level ground, whatever. Now what? Shh, quiet please. Now what? Pick a scale. So how am I going? This is the trickiest part. Riley, look at the time column, the x column. What's the biggest number that appears there? 10. How many squares wide is the bottom? You have to count. This is how I do this every time. Count how many squares we have on our graph paper. How many squares? 24? Okay. Going up by ones, I think, would be silly. I think we can actually fit 20 squares, because you said 10. I think if we want to use as much graph paper as possible, I think a good scale would be to have every one be how many squares? 2 squares. So I'm going to go like this. Skip 1, skip 2, skip 3, skip a square 4. That would be a good scale on the x-axis. I would probably take a half mark off, Cody, if you only went up by ones and your graph was only this wide when I gave you that much paper. Simone, what's the biggest number in the y values that they gave me? 15. How many vertical squares do we have to play with? If there's 30, I can go up by 2s, 15 times. Do I have 30? How many is it? Anyone? 24? Ah! So I'm going to go up, I guess the best I can do is go up by ones. Although, Duncan, I'm going to do one more thing. If I go up by ones and I label every square, I've learned it gets very crowded. So I'm going to let each square be 1, but I'm only going to label every other square. I'm going to go like this. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. Jaden, when you're done yawning, do you see kind of how we figured out a good scale? Use as much as you can. Basically what you do is you ask, how many squares have I got to play with? What's my biggest data? Can I double my data? Can I fit that in? Can I go up by 2? No. Or it may even be tougher than that. You may have, for example, 8 squares and you want to fit 40 things in. I better go up by 5s. Or something like that. Is that okay? And now we graph. What's the first point, Jaden, my friend? 2, comma. Nice and loud. I can get the 2 exactly accurately. The 5.3 I got an eyeball. It's partway between 5 and 6. I think it's right around there. And this is, although graphs, Mariah, are great for visual patterns, their limitation is they suck for reading the data off again because they don't deal with decimals well. That's okay. Ethan, what's the next point?
780.
I need the x-coordinate, please.
4.
Comma.
0.
No, 4, comma, 7.8.
7.8.
We're going to try that again. Scene 1, act 1, take 2, and action. Ethan, what's the next point, my friend?
4, 7, 8, 28.
You are ever so clever. Let's graph that. 4. And then 7.8, Ethan, I think is going to be just below 8, about there. Is that okay? Michaela, what's the next point, my joy? Comma? Okay, 6, comma, 10.4. I guess about halfway between the 10 and the 11, kind of about there. Right about now, I'm already starting to think to myself, Nicole, this looks linear. In other words, if this had been up here, I'd think maybe it's a curve, and you might look at that in grade 11, but this looks like a nice line. Looks linear. Hey, Nicole, what's the next point?
Our next point is 8 on the bottom.
Yep.
12.8.
Or you can just say 8 comma instead of on the bottom and sound nerdier, but okay, 8 comma, 12.8, okay, 8 comma 12.8, right about there, just below the 13, right?
Yeah.
Okay. These do seem to be forming a trend, a pattern. Dylan, what's the last point?
10, comma 15.
That one I can actually get bang on, because it actually sits on a grid line. By the way, eyeballing this, following it back down, do you think this graph goes through 0, 0? I don't think it does, so I'm not going to try and force it to. So I'm going to get out my ruler, the one that you've all borrowed or that you have. I'm going to lay down and I'm going to try and draw my line of best fit that goes through as many of these dots as I can. And for me, a little bit off, mine is going to look like that. I don't, you know what? I think I can fix this. Hang on. I think, no, hang on. There. I don't know, kinda like that-ish. Now, it looks to me, Cody, like my graph goes through 0, comma 3. When I did this in the last class, my graph went through 0, comma around 3.2. Yours might go through about 2.9. Yours might go through 3.4. I would not be fussy. I would basically say, if you told me yours went through 2, your ruler slipped. Or if you told me yours went through 5, I'd probably say your ruler slipped. But I always take a wide range of values when I ask people to give me a line. Hustle back, please. So, now what? It says, graph the following data, check, and then analyze the graph by finding the equation of the line. First thing we need to do is we need to find the slope. Slope is what over what? Rise over run. Now that I've drawn a line, I'm going to find the slope of the line, not of the points, and I'm going to zoom in for a second. Look up. If I was trying to find the slope, why wouldn't I use this point right here? Why would this be a silly point to use? Yeah, it's midair. Now I'm going to give you a fancy word. If it's on 2 grid lines, we call that a lattice point. So I want to find a lattice point. Now yours is going to be different from mine now. I'm going to find on my graph, nice and far apart, 2 lattice points. You guys do the same thing. So for me, my lattice points, I got a nice one right there. And I'm going to go further up and over. Oh, didn't want to go quite that far. Ooh, I got a nice one right there. The 2 points I'm going to use to find the slope are those 2. Yours are going to be different, Ariel. Unless by a fluke you happen to lay your ruler down at exactly the same angle as I did, which maybe, but I doubt it. So on your own, for your points, go rise over run. I'm going to show my work right here. I'm going to go rise over run equals. Now, the biggest mistake here, kids count wrong. So Drake, I long ago got in the habit of drawing a little dotted line triangle like that. That I found cut down on my mistakes quite a bit. You okay, Justin? Sure? Yeah. So for me, my rise is, 16, 6, What's my rise if the highest is 16 and the lowest is 6? Do the math. 10 over, and my run is 11, 2.5. It's going to be 11 take away 2.5. My slope is 10 over 8.5, and we usually decimalize these. My slope is 1.17. Last class when I did this, my slope was 1.2. I'd take that. Your slope is 1.3, I'll take that. Your slope is 1.4, I'll take that. Your slope is 1.0, I'll take that. I probably would, Evan, get fussy if you told me that your slope was 2.6. You've done something wrong. But I'll take a range of values. Question, Ethan? You okay? Now, be careful. Make sure that you didn't count the number of squares. You'll notice I said this is 11, this is 2.5, 8.5, which is 17 squares, but I'm not counting squares. I'm counting how far a distance I did from my run. So those of you that got half of that, probably you accidentally divided by the number of squares, but each square, every 2 squares is worth 1.
Oh, yeah, that's
Right?
true.
Got to look at your scale. Someone always does that, and I'm always glad they do, because now you won't do it on the test. Now, let's write the equation. The line of best fit equation. I write down my template, y equals mx plus b, except, Joseph, what's sitting on the y-axis? Which variable did I put on the y-axis? Which variable did I put on the y-axis? I'll give you a hint. It starts the word velocity. So I'm going to write v equals, what's my slope? You'll put your slope there. For me, mine's 1.17. I'm not going to use an x. Joseph, what variable is on my x-axis? No, that's the units. What variable is on my x? T for time. And then my y-intercept looks to be about 3.1. It looks a tiny bit above the 3. Yours could be 2.9. That's fine. Yours could be 2.7. Probably fine. 1.6. Nah. Is that okay, Dylan? And I'll put a box around this. This is my equation of best fit, my line of best fit. We should all be close to each other.
1.2 for time.
Yep, that's what. In fact, that's what I got last class. 1.2. Okay. Yeah, might. Give me 5 minutes. Okay. Now, part A says this. What is the y-intercept? As a number, what is the y-intercept? My y-intercept is 3.1. But what does it mean? What is it telling me? Yeah.
Where on the y-axis your line goes through?
Here's what you've said. The y-intercept tells me the y-intercept. Let's do some physics now. What does it tell? What are we measuring on the x-axis? Duncan, what are we measuring on the?
The x-axis,
What are we measuring on the x-axis?
time.
Time. So at time 0, how fast was I traveling? Right. What did you guys, you learned this in Science 10 last year. What did you call the starting velocity? You had a lovely little term or phrase for that. Ah! Duncan, this is not math anymore. You know what this y-intercept tells me? It tells me something useful. It tells me this car was moving before we started timing it, and my car was moving at 3.1 meters per second. Yours might have been something, but it means something now. Is that okay, Shana? B. What are the units of the slope? Shayna, look at the y-axis. First of all, Shayna, slope is what over what? Rise over run. Rise. Look at the y-axis. What are the units on the y-axis? There's your rise over. What are the units on the x-axis? Who remembers from Science 10, what is meters per second per second? Ah, this graph's slope is the acceleration. I don't need to memorize that if I can just figure out the units. You may have memorized graphs last year. In Physics 12, we look at about 40 different graphs. We don't memorize any of them. Instead, I teach all my students how to figure them out. This is meters per second squared, or acceleration. We're going to put this to use. Pause the video.